Hi there, today we're going to be talking about CPUs. So specifically we're going to be talking about what they are, and we're also going to delve a little bit into quantum computing and what a quantum CPU is. So on the screen right now we have 4 images. The biggest one is of a very old CPU. This is a 80s technology CPU. You can tell that from the sheer size of the stuff on the CPU. So one thing you can see is a lot of wires, and the reason there's a lot of wires is this does a lot of inputting and a lot of outputting, and so it needs a lot of channels to do that, or buses, and that's essentially because a CPU is a processor, a central processing unit to be specific, and all it does is it takes lots and lots of information in and outputs it through mechanical equations, I suppose. So imagine it like this: you put the number 10 in and out comes the number 5. What it's done is it's divided by 2. So CPUs have something called instruction sets, which are basically the things it can do with the information it has. So that's hardware. I suppose it would be hardware encoding of a sort, whereby it's mechanically built in that it can do something. So that's a traditional CPU. It's got lots and lots of what are called transistors or switches on it that can be arranged to do different things with the stuff being fed into it, using what are called AND or XOR etc. gates, which are, for instance, if this input is on and this input is on, then turn that input on, or if this input is on and that one is off, that input won't turn on. Things like that. It's a mechanical calculation, so it's just that on a massively microscopic scale, but also a massively huge scale, and that there's millions and millions of them doing that. So all the differences between the one on the top right and the one that's the large image is essentially complexity. They both try to do the same thing, but the one in the top right has a few bells and whistles added on, being that it's a lot newer. But essentially, they've both got lots and lots of transistors in them that try to achieve something. Now, the one on the right middle is the external view of a CPU. So that little thing right in the middle is actually the CPU. All the green stuff around is technically a breakout board. All it does is it takes lots of tiny, tiny connections on the CPU and brings them out to larger connectors, which are, on the large image, those large golden prong legs. So although they look pretty big, they're actually pretty tiny. And the one in the bottom right is what's called a microprocessor. It is a CPU, but again it has certain bells and whistles that makes it special, and thus is called a microprocessor. It's nowhere near as fast as the one in the top right, and might actually be slower than the one on the left, but it does things that they wouldn't do because it's extremely efficient. And that's why it doesn't need a heatsink like these other CPUs, because it does very purpose-built tasks. So that's normal CPUs. Now we're going to touch on quantum CPUs. And to do that, we'll need to make a comparison. So a normal CPU has a transistor, which is a switch. It's either on or off. And you put lots and lots of those switches together to represent data. So for instance, 1 and 0 means 2 in binary, and to represent that you'd have a switch that was on and then a switch that was off, and that would represent the number 2. And you just add lots and lots and lots of switches to make the numbers bigger and how much information it can store bigger. And then you define specific things that it can do with those switches, and you have a basic CPU. So a quantum CPU is different in that it doesn't have an on or an off. It has a on or an infinite amount of positions to the off. So where a normal CPU, if you were to read a transistor, you'd know if it was on or off. With a quantum chip, it could be anywhere between on and off. And that's what makes them special. They're very purpose specific though. So if you were to stick a quantum chip in your computer that was of equal transistor or equal number of quantum bits as there are transistors, you'd find it wouldn't be actually very good at things like YouTube or Facebook, because that's not what it's designed to do. It's designed to do complex things like breaking encryptions and things, or I don't know, it could even be used for artificial intelligence if they find some clever way to integrate it. It's just a different kettle of tea, different thing, like comparing a motorbike engine to a jet engine. They sort of do the same things, but they have their better purposes. So that was a basic explanation of CPUs and quantum bits, etc. So I would recommend, if you're really interested in this, that you go to Wikipedia and type in CPU and read up, because there's a lot of interesting information, and all it takes is a bit of time. So thank you for watching, and bye bye.